Looking at example 4 here, Ellie purchased a car for $23,000. So that is the initial value. So our value will be $23,000. And then it's depreciating or decaying at a rate of 12% per year. So 12% is 0.12, and that's per year. And the question is, after how many years? So it's N that I need to figure out. Will the car be worth $7,000? So my next equation is that V is equal to 7,000. Okay, so I can put these into Desmos and find my intersection point and then interpret that. Okay, my intersection point on this one was 9.306. Again, as long as I didn't enter anything incorrectly, comma 7,000. So what that means is that 9.3 years down the road, the car will be worth about $7,000. Not too shabby. All right, determine the point of intersection of each pair of functions graphically. So we've got two functions here. You're going to put them in Desmos, find the intersection point. Now some of these are easier to find the intersection point than others. Some of them you will have to zoom in and zoom out and try and find the intersection point, and it takes a little bit of time. Parts C and D and F were tricky ones for me in terms of having to move my graph around a lot to find the intersection points. Okay, hopefully you put those in. Now you'll notice that C, E, and F, the Y coordinates ended up being in scientific notation because they're so huge. So that leads us to talk about question number 6. When we're examining the graphs of two or more functions at one time and looking for the intersection point, we are solving a system of equations. When we learned how to solve linear systems of equations in grade 10, whether you did academic or applied, we used the method of graphing first, and then we learned our algebraic methods. Connect previous experience to in grade 10 to this situation. How can we solve the above systems algebraically? So I'm going to take a look at my first tricky one, which was example C. So let's look at this system. We have y equals 3 to the exponent x plus 15. And that I'm going to call equation number 1. So back in grade 10 we would have labeled our equations with probably a 1 and a 2. And then we have our second equation of 3 to the exponent 2x, and I'm going to call that equation number 2. So we're really solving this system here. We're trying to figure out where these two lines intersect. We're trying to find the point of intersection or the solution here. Okay, 2 to the x. So I have both of these equations already solved for y. A y equals here and a y equals here. I'm going to take and substitute equation 1 into equation 2. So substitute or sub 1, equation 1 into equation 2. So where we see the y in equation number 2, I'm going to replace it with this 3 to the exponent x plus 15. So we get this 3 to the exponent x plus 15, and that is equivalent to 3 to the exponent 2x, because at the point of intersection the y values are equivalent to each other. Now this we already saw. We saw this in lesson 1.7, I believe it was. Once our bases are the same, and we're trying to find where these are equal, the only way that these two, the left side will equal the right side, is if those exponents are equal to each other. So that means that x plus 15 has to be equivalent to 2x's. And then I can just subtract x from both sides to get rid of it here. Subtract x from here. That leaves me with 15 on the left side of the equal sign, and 2x's take away an x is just 1x. So x equals 15. There's the x coordinate of my point of intersection, which if you look up above, that is what we found. And then we're going to take that value and we're going to substitute x equals 15 into, and we can either put it into equation 1 or equation 2. I'm going to go back to equation 1, and that means that y is equal to 3 to the exponent of 15, what do we have there, x plus 15, plus 15. And that means that y is equal to 3 to the exponent of 30. Now that you can take into scientific notation. You can plug that into your calculator. It'll probably spit out scientific notation. Or we can just say, therefore, the solution or the point of intersection is, the solution is at 15 for the x-coordinate and 3 to the exponent 30 for the y-coordinate, which turns into that crazy scientific notation stuff. Okay, the last example here, determine the solution to this system. So this system actually has 3 equations. We want to find the point of intersection of all 3. What is the one point that satisfies all 3 of those equations? So we need a common point that lies on all 3. Put those into Desmos and see what you can find. Okay, you should get 2, 4 as your solution, the common point there. But I'm not going to write that down because I want you to actually do it or listen to my videos.